Hey, Bianca here. So yesterday I had you go through some different videos and kind of look up the vocabulary words that we're going to be talking about in this chapter, so get some background information on it, so that when I go through my videos, you kind of already have seen them before and understand kind of what we're going to be talking about. So you looked up, quadrantal angles. You looked up coterminal, reference angles, things like that. So I want to start to go through this section. So we're going to begin first by sketching an angle in standard position. And the way you do that, remember, is you think about your coordinate plane here. And we kind of think of it like a circle. So we know that a circle obviously has a rotation. And in order to have standard position, you have to have your angles start on your positive x-axis. So your vertex is always going to lie on your origin, so that would be here. Positive x-axis would be coming this way, also always here to the right. And that would be your what's called initial ray. Initial ray. You then have what's called a terminal ray, and it really depends on the rotation. Now, if you remember, if you go up, that would be towards your positive angle direction. So you know that that's obviously counterclockwise. So your positive angles, positive degree is going to be counterclockwise. If you were to go down with your rotation, that's going to be your negative angle. So negative is going to be clockwise. Okay, so let's look at this. If I wanted to draw something randomly, let's just do something like this here. And this would be what's called our terminal ray. Terminal ray. Okay, so we know that we have to show some type of rotation. So I always say show the arc. So initial to your terminal, show that arc. And I always make you point with an arrow so you know the direction of rotation. So we went from your initial to your terminal that way, and that's where you ended. And we knew that it was obviously a positive angle going that way. But you already looked about what was called coterminal, and coterminal would basically mean that your angle has to have the same initial and terminal ray. So is there another way to name this specific angle there? So let's just give that, a value. Let's say it's, 120 degrees. If you want 120 degrees counterclockwise, is there another way to name that same angle? So what if you were to go down? So if I had the initial ray starting here, and this time, let's use a different color so you can kind of see it. I went down this way and ended at my terminal ray there. How many total degrees would that be? Well, we know that you went down, so it has to be negative. And how many degrees did you actually go? So if you think about it, you just kind of take 360. The rotation of the entire circle. So you have 360, and you subtract the amount you already went. So you went 120 degrees. What is left? So subtract that out, and you get 240. So this would be negative 240 degrees. So notice it has the same initial ray, the same terminal ray, just noticing it's going in a different direction. What if you had a multiple rotation? So it would still have the same initial and terminal ray, but let's say I went 120 degrees this way, right? And I went, let's do a different color so you can kind of see it. I started with this initial ray. I went around one whole rotation plus that additional 120 degrees. Still noticing that the initial and terminal did not change. Well, if you went 360, one full rotation, plus the additional 120, right, you would just add them together, and you really went 480 degrees, and you would label that angle as 480. So remember, there are actually an infinite number of coterminal angles depending on the direction that you're going, and multiple rotations. The shortcut for finding coterminal would just be to add or subtract 360 each time. Okay. All right, so the next piece is talking about quadrantals. So if you have a quadrantal angle, basically the terminal ray must lie on an axis. So starting off here, initial, always in the same position, right? Let me use a different color so that you can see it. So initial is in the same position, so starting here, but this time I'm going to draw out 90 degrees. 90 degrees would be here. So that's my terminal ray. So from here to here. That is called a quadrantal angle. So from 0 to 90, right? That angle right there is quadrantal because the terminal ray lies on your y-axis this time. What if I had another one? Let's say, I don't know, we'll sketch out the next quadrantal angle. So initial. The next quadrantal angle would be this one right here. So initial to the terminal ray here, remember, show the arc or the rotation with the arrow pointing to it. And I went 180 degrees. So that is also considered to be quadrantal, okay? You also have two more, so that would be the one that is here and the one that is back over there. There's actually infinite number, right? Depending on your coterminal or the number of rotations that you would have. Let's look at the next one. So let's look at 270. So from 0, we went all the way around here to this axis right here, which is our y-axis once again. And that is 270 degrees. I could also say, like, let's say I wanted to do a negative coterminal angle of 270, right? So instead of going up, I want to go down. But how many degrees down did you have to go? Well, I went one whole quadrant, which was 90 degrees, and I went down, so negative 90 degrees is the same, has the same initial and terminal ray. Okay, so we're going to start off by sketching 145 degrees in standard position. So when we sketch standard position, I'm going to just rough sketch out my axes. We start with our initial ray. Now remember, it comes from the origin out along the positive side of our x-axis, and we need to figure out where the terminal ray is going to be located. Now we have 145 degrees, and if you think about the degrees of the rotation, we have 0, 90, 180, and then 270. Now we know that 145 is going to lie within quadrant number 2 because it's between 90 and 180. So we're just going to rough sketch it out there. Obviously this is not drawn to scale. If we take a protractor, it's not going to be equal, but that's okay. So you want to show the arc or the rotation of the angle itself. So from the initial ray, swoop it over to your terminal ray with an arrow pointing there. So that's going to be 145 degrees sketched in standard position. But let's say I want to take it another step further and I want to find the reference angle. Okay. So if I want to find the reference angle, and remember, the reference angle is always the positive acute angle that is formed with the terminal ray and the x-axis. So I want to think about the terminal ray as the hypotenuse of the triangle, and we're in quadrant number 2. So you want to drop down a perpendicular to the x-axis, forming this angle in here, which we're going to call theta. That's going to be our reference angle there. Now, if we think about it, we rotated 145 degrees. We need to figure out how many more degrees are we going to be going in order to get to 180. So what you would do is you would take 180 and subtract the rotation that you've already gone, which is 145 degrees. Okay, so we have 180 minus 145. When we do that, we get 35 degrees. Now 35 degrees is going to be this angle in here, which we call theta, but it's also going to be called our reference angle, the positive acute angle that is formed between the terminal ray and your x-axis. Okay, so let's do a couple more examples. Remember, this video is just all about putting everything we already spoken about or learned about together. The second one, B, we have 240 degrees. So we know that the initial from the origin out, 240, well, we know that this is 180 and this is 270, so we know that 240 has to be in here somewhere, right? So remember, we're just rough sketching it out. Show the rotation, so from the initial to the terminal with your arrow, and that's it. So that would be the sketch in standard position. But what if I ask something further? If I want the reference angle? Remember, the angle that is formed from the terminal ray to your x-axis. Now this time, you're dropping your perpendicular up. And this is the theta that you're referring to. Well, if the entire thing was 240 degrees, right? Think about it. I went 90, I went 180. How many degrees further did you go? So you can take the 240 degrees that you already have, subtract out the 180 that you already went, and when you do that, you have 60 degrees. So this angle in here is 60 degrees. So your reference angle is 60 degrees. And then the last one I threw in there, 412 degrees, you notice that obviously that is larger than one rotation because one rotation is 360. So let me just sketch that out quickly. We begin with our initial, which is here. One full rotation is 360, right? So we have 0 slash 360, 90, 180, 270. So we know we went one full rotation all the way around plus some, but plus how much extra. So we need to figure out technically, like kind of like your, not shortcut, but the way I like to think about it is I want to think about what is a coterminal angle. So we know we find coterminal by adding or subtracting 360. Well, if I want it to be within this one rotation, I have 412 degrees. I can subtract out 360 so that I can figure out how many more degrees we have left, right? Subtract out the whole rotation that you already did. And when you subtract that there, you should get 52 degrees. So you want an additional 52 degrees. So 52 degrees we know is obviously between 0 and 90. So we're just gonna rough sketch it out. I don't know, somewhere over there, right? So I'm gonna continue my arc or my rotation to that angle, point at it with an arrow. So that would be the sketch of 412 degrees in standard position. But what if I ask an additional question? I want what's the reference angle? Well, if I want the reference angle, remember, you just want that positive acute angle, right? Reference angle is a positive acute angle. From the terminal ray to your x-axis, it's this angle in there. Well, if we went 412 degrees, right? We did one whole rotation plus that little bit. We technically already found it. It is 52 degrees, okay? So remember here, positive acute angle. We already have a positive acute angle. It's from the terminal ray, drop to that x-axis there. So 52 degrees is the reference angle. So just kind of putting everything together. We put together this sketching in standard position. We did the coterminal. We did the reference angles and quadrantals. Okay, all in this step. All right. So what if I wanted to figure out if 150 degrees and negative 570 degrees are coterminal angles? So I could sketch them out if I wanted to, but remember, if you're thinking about rotations, we want to know how many rotations would that even be possible. So what you can do, remember my little shortcut, is just kind of add or subtract 360 every single time. And if you get the other angle, then we know that it is a rotation of the previous. So if I start with 150 degrees, 150, and I want to see if I can end up at negative 570, am I going to be adding or subtracting 360? Now I know that I need a negative number, so I'm going to subtract 360. So I have 150 minus 360, and when you do that, you get negative 210. Now negative 210 is not negative 570, but I've already got one rotation. Let's try another rotation. So I'm going to subtract 360 again. When you subtract 360 again, 6, 7, 5, you get negative 570. Well, negative 570 is the original angle that we had asked if they are coterminal, and clearly it is a rotation of it. So yes, these are coterminal, meaning they share the same initial and terminal, right? All right, so quickly, just another way to find the reference angles. A lot of times people use some formulas. I'm not really a fan of memorizing more formulas, but I like to do it, remember, based on drawing it out or sketching it out and then figuring how much more I would need to go or whatever it is that I'm given. But I am going to provide them to you in case you do want them. If we're looking at quadrant number 1, the reference angle is just theta, or just the angle that you're given, because remember, a reference angle is a positive acute angle. All the angles in quadrant number 1 are acute, right? Meaning less than 90. If I want a quadrant number 2 reference angle, I want to take 180 degrees and get rid of the angle that we already have so that we have what's remaining. So you would take 180 and subtract the angle. If I'm in quadrant number 3, we went 180 plus some additional piece. But how much additional piece? So what you want to do is take the angle that you're given and take away the 180 degrees that you already went or rotated. And then lastly, for the fourth quadrant, we know that there's 360 degrees in a full rotation. You take the 360 and you subtract out what you've already went, which is the angle, and that will give you what is remaining. So these are the kind of like rules or formulas that you can use in order to find the reference angles. All right, so let's look at these examples. So we have an angle in each one of the different quadrants. They're sketched in standard position. I want to find out what the reference angles are. So I'm just going to quickly run through them. Looking at A, remember if we're talking about the reference angle, the angle itself actually is your reference angle because it's a positive acute angle. So remember, drawing your triangle, dropping it down from the terminal to your x-axis, it forms theta in here. You already have 50 degrees. 50 degrees is your reference angle. Looking at B over here, doing the same thing, we want to find that triangle or that reference angle. So you drop down the perpendicular, there is your theta. But since you're in quadrant number 2, we need to figure out how many more degrees you need to go to get to the 180. So we have 180 minus the rotation that you've already gone, 170, to figure out how many more degrees you would need to go. So that would be 10 degrees. So 10 degrees is the reference angle for B. Looking at C here, we're creating our triangle. So I'm gonna drop it to my x-axis, and there is the theta that we're referring to. So for quadrant number 3, you wanna get rid of the number of degrees you've already gone, or full quadrants. So we have 220 degrees. We have already gone 2 full quadrants, which is 180. So if we subtract that out, we would have what's remaining here. So we want to subtract that and we would have 40 degrees. Now 40 degrees is how many more degrees you would need to go to get to the 220 from the 180 that you were. So 40 degrees is your reference angle for C. And then for D here, we have a quadrant 4 angle, so dropping my perpendicular, there's the theta we're referring to. To find that angle or that reference there, think of the whole rotation as 360. Take away what you've already gone to find out what's remaining. So you have 360 minus 290, and you're left with 70 degrees. 70 degrees would be how many more degrees you would need to go in order to make that full rotation, so 7 degrees is our reference angle. Okay, so these are the very last examples that we're going to be doing. So noticing one that is larger than a full rotation and one that is negative. So you have examples of everything. So if I wanted to sketch the first one in standard position, noticing that we went more than one rotation. The initial ray, once again on the positive x-axis there. We went one whole rotation, which is 360. So I'm going to sketch in that rotation there. But we went an additional amount. We need to figure out how much additional did we go. Now what I like to do is always find the positive coterminal angle. That would be between 0 and 360, one whole rotation, so that we know what quadrant it's in. So if I was to subtract 360 here to figure out how many more degrees I would need to go, right? I notice that I have 45 degrees. I have 45 degrees more to go. And 45 degrees we know is in quadrant number 1. It's about there. So we're gonna just continue the rotation to that terminal ray with an arrow pointing at it. Now that would be the sketch in standard position, but what if I asked you to find the reference angle? The reference angle, remember, is the positive acute angle formed with that terminal ray and the x-axis. So if you drop down that perpendicular, this is the theta that we're referring to. How many degrees more than the full rotation did you go? We already found that there. It was 45 degrees. So 45 degrees is your reference angle. This last one over here, I'm just going to sketch this out quickly. Negative 65 degrees. Now negative, remember, tells us that we're not going up anymore. We're in the counterclockwise direction. We're now going clockwise. We're going down. We're going down 65 degrees. Well, we know that each quadrant has 90 degrees, so 0, 90, right? We know it has to be between that, so I'm just going to kind of sketch that out. It has to lie in that quadrant. It's not more than 90. We went down, so show that arc and the arrow. We went down 65 degrees. Now remember, that negative tells us direction down. So there's the sketch in standard position. But if I want the reference angle, remember, the reference angle, remember, is the acute angle that is formed, the positive acute angle. So if I was to drop the perpendicular in, here's my theta. Notice that it is 65 degrees. Notice I need to take the positive measure because it's a positive acute angle. This is negative. The negative only tells us direction, so it's telling us down, but the reference angle itself is positive. All right, and that's it for today. Just kind of recapping everything so far with the trig stuff. All right.